Here's the two mistakes. The first mistake is not developing a clear understanding of how the energy using equipment delivers that service, whether that service is cooling or lighting or providing heat or whatever. The second mistake is overestimating the savings from the energy efficiency measures that you're proposing. Two big mistakes energy auditors make. As an energy auditor, basically your job is to identify the maximum amount of energy that can be saved in a building or the facility that you're auditing, and that's within your client's budget and payback period. Now that's presuming that your client, or that is the company that's hired you to figure out how to save energy and wants you to present a business case, that's presuming that they trust you and will act on your advice. Now I could talk a lot about that. Today I want to focus on what you need to do in order to maximize savings. I want to focus on two mistakes that energy auditors commonly make. I'm Bruce Strauss. I've got a lot of experience in energy auditing, and I also have got a lot of experience in assessing energy audits. Now, the mistakes that I'm going to mention are related to the identification and quantification of the savings measures associated with the delivery of some service enabled by energy. So let's look at the first one, which is not developing a clear understanding of how energy using equipment works, why that equipment is needed, and how it actually goes about delivering that service. When you don't have a clear understanding of how something works, you're going to miss many opportunities to save energy. And if you don't know why it's needed, you're probably going to miss out on even more opportunities. Here's an example. A large building, let's say it's a commercial building like a bank or something like that. A large building, let's say it's a sky-rise building, has space cooling provided by a water-cooled chiller. Now, if you don't understand how that cooling is delivered by that water-cooled chiller and all the other equipment associated with the delivery of cooling, probably the only savings measure that you're going to come up with is, okay, well, let's find a more efficient chiller. As a result, you're going to miss out on a whole heap of savings opportunities. Such as, well, let's start asking the question, why do you need cooling in this building? Is there any way that we can reduce the need for cooling or even eliminate the need for cooling? Now, once you start asking that question, then you realize that you need to know about the main methods of heat transfer. How is heat getting into the building? Why is it hot? Why do we need cooling? You need to know about radiation, conduction, and convection. The cooling is being provided to keep people comfortable. You also need to know about the properties there, specifically humidity. And you need to know what is a comfortable temperature and humidity. If you don't have any clue about these topics, well, then your advice is going to be pretty bad. And once you start asking this question, thinking about it, you start to realize, hey, maybe I can reduce some radiant heat gain into the building. There's some buildings that get full sun, some windows that get full sun. There's a lot of radiant heat coming in there. How can we block that radiant heat? You can start to look at the conduction of heat. What's the insulation like? How can we prevent the conduction of heat? And then you start to look at convection, the unwanted air movement. Well, how much air is leaking into the building or going out of it? If we bring in too much air, well, once you start to ask these questions, maybe you're going to come up with some measures that are going to give you some really good savings. And of course, this depends on the existing conditions of the building. And you may even actually start to look at alternatives to using the chiller, such as creating air movement to provide cooling. Now, an air conditioning system based on a water-cooled chiller is actually a pretty complex system. And where there is complexity, there may be many an opportunity. You know, I used to love doing energy audits of award-winning green buildings. You think it's a green building. Why would you want to do an energy audit of a green building? It should already be efficient. Well, that's not so much now, but often award-winning green buildings used to be incredibly complicated buildings with really complex systems trying to deliver the nth degree of energy efficiency. And invariably, a lot of that complexity didn't work well. So I just go in and identify the inefficiency, show them how to fix it, and you get good savings. So when there's complex systems, there can be energy savings in every stage, right from the condenser on the rooftop through to the registers, the duct registers that push cold air into the room. So there's going to be opportunities probably with the cooling tower fans, the condenser water pumps, the condition of the cooling tower itself, the chiller itself, the chilled water pumps, the air handling units, then the distribution of air, supply of fresh air. And the opportunities are not just with the equipment, not just replacing bits of equipment, it's how the equipment is configured, controlled, how it interacts with each other. And you need to understand how changing settings for one item can cascade all the way through to impact energy use of other items. So it's actually quite complicated. And then you might start thinking most air conditioning systems use the air that is providing ventilation, fresh air that we need, to also provide cooling. Now, then you start to ask questions. Well, is the ventilation adequate? Is it being overventilated? Is energy wasted by cooling too much air? Or perhaps it's being underventilated and you've got problems with CO2 levels being too high. So suddenly in thinking this way, not just think about the chiller replacement, you've gone from just having one way of saving energy to probably 10 or more, depending on the particular building and how well it was designed and is operating. So now let's look at the second mistake, which is overestimating savings. And fundamentally, I think that there's two reasons why savings are overestimated. The first one is psychological. As an energy auditor, you want to look good. You've been paid, possibly paid quite well, to provide advice on how to save energy. And you actually want to show that you're worth it, that you're delivering value. You want to look good in the eyes of your client. This means that very often you're going to, perhaps even without being aware of it, be biased towards exaggerating the savings. The second reason is that savings are often overestimated. Goes right back to the first reason, which is actually because you don't understand how the energy using equipment actually works, how it delivers that service, whether that's cooling or lighting or whatever it is. Because when you don't understand how energy using equipment actually works and how it's operated and why it uses energy, then you actually can't calculate the savings. You don't know how to calculate the savings because you don't know what you're looking at. You know what the savings may be. Or perhaps you rely on others. So you go to a supplier, an equipment supplier, and he says, oh yeah, okay. By doing that upgrade that my equipment helps deliver, my rough estimate is that you'll save from 15% to 20%. And so you say, okay, going back to that psychological bias you had before, oh yeah, okay, well, let's presume the savings is going to be 20%. And then you'll say to the client, the rough estimate is, you'll say the savings will be 20%. Big mistake. Big mistake. Now, the chances are that the equipment supplier hasn't even been to the facility and every energy efficiency measure is custom tailored to that facility and the savings are dependent totally on the conditions of that facility and how it's configured and operated and so on. So it's very facility specific. It's not necessarily just equipment specific. Well, for example, for lighting. Lighting, you're replacing fluorescent with LED. Okay, yeah, sure, the savings depend on that LED light, but they also depend on, well, how long are those lights in use for? How are they controlled? How are they switched on and off? So it's not, and the equipment supplier may, for example, assume that the lights are on 3,000 hours a year. Maybe they're only on 1,500 hours a year. Savings will be half what the supplier estimated. So, of course, the supplier is interested in selling the equipment that helps deliver the savings. And thus the supplier is also probably likely to exaggerate savings because, well, maybe they're not going to be held to account. So why not just inflate the figures a little bit? If, however, you do know how that equipment works, when it works, why it works, the load profile, well, then you can start to do calculations rather than guess at percentage savings. So if you're looking at an outside air system, you can look at the psychrometric chart. You can start plotting humidity, enthalpy, and start to figure out what the savings is going to be from, say, fitting an adiabatic, retrofitting a condenser to be an adiabatic condenser, an air-cooled condenser to be an adiabatic condenser. And then instead of making assumptions, you can start to take measurements to justify those assumptions. So you're not just guessing at what the outdoor air temperature is, you're looking at measurements of the outdoor air temperature and humidity when doing those calculations. And then you'll be able to have much more useful and in-depth conversations with the suppliers and others. And maybe you'll even come up with an alternate solution that's better. And even if in the end the savings are less than what you had hoped for, maybe that supplier indicated they might be, that actually may not matter that much because if you have a really good understanding of how and why the equipment uses energy, you've probably identified not just one savings opportunity, but several. And in aggregate, the savings add up to quite a lot of useful savings. So it's not actually easy to deliver good energy audits that your clients can trust. You've said the savings will be so much, and when they implement it, the savings are actually more or less what you said they would be. And you've also identified not just one savings measure, but quite a few. And if you want to learn more, have a look at the investment grade energy auditor certification and training in the link below the video. The training that underpins this certification is divided into two parts. The process of doing an energy audit and energy using technologies. This helps you develop that more in-depth understanding. Yeah. And it's a great starting point to developing that good understanding that you need in order to deliver audits that your clients can trust.